Hello, everybody. Brian here from quantlabsnet.com. I'd like to show you maybe five projects that I've converted, generated from random things from the internet. Uh, but they're going to get posted on my GitHub repository. I haven't posted anything there in a long time. I just want to show you that here, that this exists, and expect to see these projects up next little while. So these are the projects we're talking about here. These are all in Python, and I'm going to go through each one, with the exception of this MCP1, MCP server, and Omar, which doesn't really work. First one I'll take a attack at is this variance swap replication. So this one, just so you know, we have a Python script along with usually a README file. So let's check out what this does. So this README file, basically Python designed to address your query on replication strategy for variance swaps. So it's very institutional level. So we got the output here, and this will underlie price path using a geometric Brownian motion as a common assumption for asset price. Replace a portfolio, build the options portfolio, and add long future position. Calculate payoff. So this is all the stuff I've talked about in options with payoff. Build, combine portfolio replication, variance swap payoff, including the log contract component. Output the results and plot to illustrate the mechanics. And then there's obviously a script in here as well. So we've got here libraries defining the inputs. We're going to show the price paths. It's going to use Black-Scholes for simplicity. Replicates a portfolio and goes through a log contract, realize variance payoff, and all the detail there. I'm not going to go further than that, but I'll just show you those runs. Yeah, it's called variance. Boom, does this thing, and here's the final output. So you can see here in the output, actually right here in the plot, we have two distributions of a log contract as it's stated. I get it straight. Distribution of realized variance. So here's the variance, the frequency, and same with the distribution of log contract payoff and log payoff. So that's the first script. The next one we can take a look at from the top here. Transformer to financial time series. Okay. And again here we've got the README. Okay. So this script is a process of financial time series using transformers covering input matrix expansion, normalization, embedding, positional encoding, transformer mechanics, designed for clarity and correctness. Demonstrates how to apply transformers to financial data as transcribed in an article. Takes the time series, returns fundamentals, normalizes it, embeds it into a higher dimension space, adds positional encoding, runs it through a simple transformer, and outputs the features downstream use, prediction, or optimization. Okay, so let's see how that runs. So this one's called Transformer using Python 3. Okay, maybe this one might take a while. There we go. So one of these, there we go. So this one's using Torch, okay? The machine learning library from Facebook. And you can see it kind of runs. That's all I wanted to show you, um, that it runs. You can go through the source code and figure all that out as well. This is sometimes beyond my pay grade, I guess you could call it. So now we're going to look at one called calculating present value Greeks from finite difference grid best practice. Okay. So here, okay, so we have a README file and the script itself. So let's see what this one does. Okay. So here we've got so here we're using a best practice. Uh, we're interpolating. So okay, trying to include a spot price. A grid simplifies direct access, making a grid less reusable for comparison across different spot values. This introduces discretization, geez, errors when using it compared to grids, as each spot price requires a new grid setup. Primary drawback is inconsistency in error profile, making it harder to analyze sensitivity or perform Monte Carlo style evaluations. So all of the verbiage there, let me just show you that this works. The whole idea is just to show you the structure of it, what it is, and uh, that it's working. That's all I care about, and it's just been picked off the internet randomly, and it works. So here we have a Black-Scholes American call. Price is given a delta plus the gamma. Then it's using a Heston model with all those grids. Grid shape, V grid, value grid shape, and then we have a Heston option used with a value delta and gamma. Okay, so you can go through the source code on your own time. And we have another one here called the last one called the macro aware risk parity. Now, I've talked about risk parity in my reports before. It's kind of like the core equilibrium between a put and an option in any asset. And that's what a lot of the HFT shops will use to see if there's an opportunity there when the parity is off, the equilibrium's off in the risk parity. So this is a lot more advanced. Okay, let's see what it does here. All right, so here we're measuring equity, duration, risk parity position. So we're using volatility, target allocation, equity, and fixed income. Macro awareness, incorporating macro economic indicators, excess inflation, excess GDP, and overconfidence scores to generate a composite economic slack score, which adjusts the position size. So here it does backtesting to simulate strategy return on historical data with macro signals and a couple of key assumptions, simulate or approximate the scores across inflation, excess GDP, and overconfidence using dummy data or basic calculations based on the article description for accuracy. Integrate with actual economic data source like Fred or Quandl. Volatility targeting position scale to a 10% annualized volatility target as mentioned in the article. And again, with my stuff, I can measure in annual volatility. So let's see this thing run. Macro aware. So this was the tough part, to download the data from Yahoo Finance, but I got it to sort of in a working situation. There's a chart there on cumulative returns based on macro synergy article, and sample risk parity, macro aware risk parity. And that's all the way back to 1992. And you can see the output here. We have here sharp equity return, bond, risk parity, macro aware, annualized return, bond return, risk parity, macro aware. And that's it. So that's all everything they're running. If you want to know more and want to know more what I do, just to kind of understand what I do, just come over to the quantlabsnet.com, click on the link tab here at the top. You can sign up and get yourself a free C++ HFT book. Don't spam anyone. All your info is kept confidential. Okay, thanks for watching. Have a good day.